All right, CNT120, Chapter 4. We're on the section on some troubleshooting tools. So we've used some commands already. We're going to add a couple to our plate on this chapter. One of them is netstat. This is going to display TCP/IP statistics about any TCP/IP connections that a host may have. So I could see what connections my host has, but I could also see what connections something like my server has. And something like a server, I'd want to know what connections are open. Do these ports make sense? Or did a recent update open up ports I'm not aware of? So this would be a way to kind of see that. So with netstat, here's a bunch of different options that can be done to see specific aspects of your TCP/IP connections. Let's do one or two of those here. I'm going to open up my command prompt here, and I'll clear my screen. And let's just do the basic netstat on, let's see what we got here on this computer. I see a lot of local 127.0.0.1s, but down here I have just a couple open that were established previously going to a specific port. If I go to my browser and maybe open up a web page or two, let me go up here and open up a web page or two. Let's go to here. Let's go to here. I'm just opening up a couple web pages on the side. And now let's do a new netstat. I'll probably see a few new connections down here. You can do it. Yep, we got a couple new connections down here with different ports connecting to these websites. I open up XPN and WRTI and so forth. I open a couple websites that stream music. So we have a couple extra ports open now. That's what that allows me to see. And again, if I use some of these other switches here, I can see specific aspects of these connections. That's what that's handy to do. Go back to my command prompt, see if it closed out yet. There we go, that'll work. So that's what that allows me to see, which can be handy to see what ports are open, if it's something that should be open or something that should not be open. Traceroute allows us to see a path that we're taking to get to a destination. I can do something like, let me go here real quickly. Let's do a trace RT to something like www.hack.edu. Now this is going to take a minute because it literally goes to the first step, waits for an error message to come back, then it goes 2 steps, waits for an error message to go back, then it goes 3 steps, waits for an error message to go, does 4 steps. It actually is a very sneaky process, and along the way, and that's what they're showing you here, I basically send a message with TTL1, it gets here and it sends an error message back, and I'm like, oh, thanks, appreciate it. Then I do 2, this sends an error message back, I'm like, oh, thanks, appreciate it. Then 3, and I keep going, and that allows me to basically print the pathway to my destination. Now, where this comes handy is if I'm managing something like Hack's network, and I know the path it should take to go from Harrisburg to Lebanon, I can trace that and see, is it working? And it even gives me a little instance of delays and so forth. But if I don't get there, it gives me an idea of like, well, I got this far and we're having an issue. That lets us know maybe where to begin troubleshooting. Is it something in our equipment or is it something in the provider equipment? Now, you'll see on this trace here, we have a couple timeouts. There's some equipment programmed to not respond to this stuff. They're like, hey, I'm busy. I got stuff to do. So that's not too surprising that you would get that. But if you're tracing on your own network, those things, you should recognize those steps. And that would allow you to start troubleshooting, maybe know where to start troubleshooting if you have a connection issue. That's what's handy with traceroute. And if I'm working on Windows, I'm going to do trace RT. That's my command, trace RT. If I'm doing something like Apple or Linux, I'm going to do trace route, R-O-U-T-E. And last but not least, if I'm working on a Linux machine, I can run what's called TCP dump. This is essentially Wireshark at a command line. That's the kind of thing you would get here. This was actually a ping done on a Linux system, and you can actually see the request and reply, so this is actually kind of like a command line Wireshark, if you will. Go back to my trace right here. I'm going to close that out. Control C will stop that trace. There we go. I don't need to keep letting that run. At the end here, I put a couple charts in to remind you of things we've done so far. We've used ARP to look at our MAC to IP address mapping. Last chapter, we did DIG and NS lookup. Chapter 3, we did dig and NS lookup. We've used ipconfig and ifconfig to look at our IP settings. This chapter, we looked at netstat. We talked about nmap before in helping us map out devices on a network. This even lets us know ports that are open on that device too. That's helpful as well. Ping we've used to test for connectivity. SSH for remote access. Telnet for, well, old school remote access, but we don't use because of security. TCP dump for basically Linux Wireshark, command line Wireshark, and I can filter all kinds of different things there. And then trace or trace route, showing us the path that something is taking that I might begin, to let me know where to begin to start troubleshooting. They remind us here about dealing with certain network problems, duplicate MAC address. It's kind of a rare problem because those two devices would need to be literally kind of like in the same room, if you will, or at least on the same switch. As long as they're on different parts of the network, they probably will not even be duplicate. But you can actually get a NIC that you can reassign in case that would be an issue and reassign the MAC address on it. And then traceroute and ping ends up using that a lot to test connectivity or how far I get connectivity. So there is Chapter 4.